Good morning, all. Myself, Sangeetha, working as Assistant Professor in SNS Project Engineering in IoT Department. This session, we're going to discuss about deadlock concept. So, deadlock means what? So, if the transaction is waiting for the resource, if the resource is not available on the particular moment, the transaction has to wait for a long time. So, if the situation is persist for a long time, the situation is called as deadlock. So, due to that, there will be a long queues waiting for the resources. So, we have to handle it properly, otherwise, it leads to overflow or traffic in that transaction schedule. So, consider the partial schedule. So, T3 and T4 is a transaction. So, the T3 it occur exclusive lock on the B, so and read the value of B and make some modification on the B, and after that the value will be returned by transaction T3. So whenever the lock is occurred by the transaction should release the lock after its completion of the work. Otherwise, the no one transaction will use that. So this is the scenario. Based on that, lock control manager will granting of lock. So if the T4 is requesting for the lock on the item B, but the lock is not released by that transaction means, so no process will execute on both the sides. So this situation is called as deadlock. So, for example, we can technically, if you want to say that neither T3 nor T4 can make progress. So, because if the transition occur as add lock, it could be possible. But if the transition occur exclusive lock on item, so until it releases the lock, no one will access that lock for sharing the data. So this situation is called deadlock. To handle the deadlock, one of T3 or T4 must roll back. So either T3 or T4 should roll back, and its lock is also should be released. Okay. So in this diagram shows that that situation is called as starvation. Starvation means waiting for the resource. The transition is wrongly waiting in the queue is called starvation. So concurrency manager is perfectly designed to handle this kind of situation. So example, transition may be awaiting for exclusive lock on an item while sequence of other transition request and granted share lock on the same item. But so the same transaction is repeatedly rolled back due to deadlock. So if the deadlock situation arises, either the transaction should be rolled back. So the concurrency control manager can be designed to prevent this kind of starvation scenarios. So two-phase locking protocol is used to ensure the conflict seriable schedule. So one is growing phase and one is shrinking phase. In that growing phase, more number of locks can be obtained by the transactions. In that phase, the transaction may not release any lock. This is called the growing phase. Another one phase, shrinking phase. Once after that, the transaction should release the lock. What are all the locks can occur? So as occur. So the transaction may not, during that shrinking phase, no one transaction will occur any longer. So this ensure the serializability can be proved by the transaction by log points. So log point is setted. So in growing phase, the log occurring takes place. When in the shrinking phase, the log release will takes place. In that two-phase locking protocol, there are another two kind of locking protocol is also there. Strict two-phase locking. So the transition must hold all kind of exclusive lock till commit or abort. So it ensures the recoverability and avoid cascading rollbacks. The rigorous two-phase locking protocol, it must hold all the locks. In that previous strict two-phase, only hold exclusive lock until it commits. But in rigorous two-phase locking, it hold all locks till commit or rollback about the life. So the transaction can be serialized in order which they commit. Okay. So the log conversions will be like so. Growing phase and shrinking phase will be like this. So the log table implementation of blocking. The log table will be prepared by the log manager, implemented as a separate process. So the transaction, what are all the transactions are executed, those data will enter in the log table. and it have the information about the lock and unlock details, which transaction unlocked the data and unlock. So these kind of data login register will holded by the lock manager and lock table. So based on that, it sees which are all the locks are granted and released by the transactions. The log table diagram shows like this. So it will have the record of sanction logs. So the colors are intimating that dark rectangles indicate granted lock, light color indicates a waiting request, the blue color shows, and empties are the waiting unlock mechanisms. So likewise, the log table will work. That's all about deadlock.